Right, so can everyone hear me? Yep.
Yes.
So yeah, I'll be talking to you a bit about my PhD project. First, I'd just like to say thanks to GRDC and to Saget for funding my work, and also to my supervisors, James Edwards, Glenn McDonald, and Hayden Kuchel. So, first off, let's start with wheat breeding. So what's the goal with that? Well, we want to produce better varieties through selecting traits. So recently, this is done mostly with molecular technologies like molecular markers and genomic selection. But this is at the point now where this information is really readily available to breeding programs, whereas it used to be a bottleneck. But both of these tools are still really underpinned by phenotyping. So that's going out and observing the physical characteristics of the wheat growing in the field. So if we look at a plot of wheat in terms of the wheat breeding program, what do we actually want to look at with it? Well, we might want to look at things like grain yield or flowering time, head numbers, disease. We might want to look at the height, or we might want to know how much biomass is in the plot. So each of these things by themselves isn't too hard to measure. It's pretty easy, but when you start looking at lots of plots, it becomes difficult, especially with things like biomass where you have to destructively sample. And so this is now creating a new bottleneck in the breeding program where we have all the molecular information we want, but not all this phenotypic information. So just to illustrate that a bit, here's 30,000 plots out at Roseworthy at AGT's main breeding site. And when you look at it in that scale, the idea of going through and measuring each one of those plots just becomes unfeasible. Even more so when you think about South Australia and having 100,000 plots spread across it. So this is really where my project fits in, looking at how we can use new technologies to try and speed up this phenotyping process and make it a bit easier for plant breeding. So over the past year or so, we've been working on this prototype imaging boom. So this is a collaboration between AGT, UniSA and Lima Grain. And so we've put this together with a couple of different sensors on there. So up the top there, we've got 4 digital cameras, 2 on either side of the boom. And we also have 2 LiDAR units, which are a 3D laser scanner. So basically what we do is we drive this boom through our plant breeding trials, and we measure 1 plot either side as we go. All of that information is triggered, all of that capturing is triggered by an RTK GPS in the tractor. And then all of it gets sent back to a laptop in there. And so we've got all the data ready to go when we get back to the office. So now I'll just talk to you a bit about both of those different sensors and what I've been using them for, and sort of how I think they fit into the context of plant breeding. So first off, digital imaging, and we're taking photos down into the plot, so directly from above. And sort of the simplest thing we do with this is digital imaging segmentation. So basically selecting parts of that photo and separating them out and analysing them. So here in this example, we've got the original image, and then I've taken out the background there, so there's no soil, it's just plant material, and you can use that for things like ground cover or potentially early vigour early in the season. And then I've gone a step further here and just separated out the yellow. So in this example, I was looking at physiological yellowing in wheat, so I wanted to measure what percentage of that leaf area was yellow. But yeah, you can use it for other things like the ground cover. You can also use it for senescence. And I've tested it also for measuring septoria within a septoria nursery. So looking at that data in a bit more detail, I obviously have those digital scores I've taken, but also visual scores I've gone and made myself in the field. And so when we look at the relationship between the two, it's pretty good. I don't think you can complain too much about that. But in terms of plant breeding, what we can then look at here is the heritability. So you can think of that as genetic repeatability, or in essence, it's a measure of accuracy that we use in the breeding program. So looking for my visual score of the data, it's around 48%. So that's pretty good, it's a fairly heritable trait. But when we look at my digital score, it's 73%, so we saw a nice big increase there, which means that using that digital data within the breeding program should be more reliable. Sorry, I'm not sure if I said visual or digital there, but using the digital data in the breeding program should be more reliable than the visual data. So that's kind of what I've been doing with cameras. Now let's have a look at the LiDAR. So like I said, this is a 3D sensor, it's a laser scanner, and it gives us data that looks like this for each of the plots. So this is just coloured based on height, just to make it a bit more visible. And you can see here the 5 individual rows of wheat within that plot. So I mean, that's some pretty cool looking data, and we then have that for each of the plots in our trial. But what can we do with that data? Well, the first thing we can do is look at height. So here we have that same plot, but looking at it from the side, and you can see how we would measure plant height with that. And again, comparing these LiDAR-derived heights with some manual heights I've taken out in the field, we get a really nice correlation there. And then we look at the heritability, and it's the same for both. So we're not seeing an improvement in accuracy there by using the LiDAR, but what we are seeing is an increase in speed, where being on a tractor, you can drive it through the field pretty easily, and I don't have to be out there with a ruler measuring all of these plots. So something else I'm interested in with the LiDAR is biomass, which is particularly hard to measure, especially within plant breeding. So you have to take biomass cuts, so cut out part of the plot, dry it and weigh it, and if you do that too many times, you don't have any plot left. So here we have that same LiDAR plot, but looking directly down. So you can start to see some of the sort of fidelity in that scan. You get individual leaves in there, and you can even start to make out heads. And so again, comparing manual biomass measurements with this LiDAR-derived biomass score, we get a pretty good correlation. It's not perfect, it's obviously not as good as the height one, but it's still pretty reasonable. And the really exciting thing about this in terms of plant breeding is when we look at the heritability, we go from 15% with the manual measurement, which is pretty average, you wouldn't really want to use it, to 62% with the LiDAR, which is really good. And it means that this data should be pretty useful within the breeding program. So on that note, what do we actually do with the data in the breeding program? Well, the short answer is statistics. So basically we get all this phenotypic data and feed it into things like mixed linear models and multivariate analyses. And basically what that does is it gives us a more accurate analysis, and ultimately it leads to us predicting better future varieties to extract from the breeding program and release. So I guess just a short summary on that. I've been looking mainly at the digital imaging and the LiDAR. So the digital imaging and cameras, they're easy to use. Even though I have it on a tractor, you don't have to. You can use it on foot. You don't need GPS or anything. You can do all of that analysis with free software, which is really good. And you can look at traits like ground cover, potentially disease, and also in future we're working towards things like counting objects, so heads and plants. Then we have the LiDAR data, which is unfortunately not so easy to work with. It needs to be on some sort of vehicle and have spatial information fed in so that you can make that 3D data. And it all has to be done with custom software. But the information we're getting for traits like height and biomass is really promising. So for the breeding program, we're getting some really good looking data. And I guess the next step for me is to repeat this all again at a much larger scale this season and collect more data and see how it feeds into those statistical analyses. So I guess just in terms of looking forward, where do I think this technology is going? Well, definitely plant breeders and researchers I think are going to be using it, but it's also showing really promising potential for advisors and growers. So I'd just like to thank the UniSA PBRC, as well as the AGT Roseworthy team and Lima Grain for their help on this project, as well as Saget, GRDC, University of Adelaide Ag Food and Wine, and the ARC for their funding. Thank you.